All right. Question 2 says, give the equation for r in terms of a. So what are you going to do? Let's go, George.
First of all, you times the a by 4.
Why?
Or times it on 4 by both sides to get rid of the 4.
Right, you want to isolate the r, so George is going to multiply both sides by 4. So you get 4 a's are equal to 9r squared. Then what do you do?
Divide them both by 9.
Right, so this is 4a divided by 9 is r squared. So if I want to get r, what do I do?
Square root.
Yeah, take the square root. So this is achieved. R is equal to, you don't have to write plus or minus, but it's probably better. Square root of 4a all over 9. This is a quadratic because it's r squared, so I would always write plus or minus.
Do we get it right if we just put equals?
If you put equals what?
Just without
Or
Yeah, if you write it without the plus or minus, they're saying they'll accept it. Other options for this are, you could write this as equals. The square root of 4 is 2, square root of 9 is 3, so you could also write it like this. Right? That's another possibility. My pen is not working properly. Okay, next one. Shall we go on to the next one?
Yeah.
This one says the perimeter of this, the outline of this house is a pentagon essentially, and they tell you what the perimeter is. So you've got to add together all the sides, including AB. This I think is, it's anyway, let's just do it. Right, the perimeter is equal to this side AB, right, plus the 4 sides, 1, 2, 3, 4, plus, so we write this as 4x minus 2, plus this 8x plus 3, plus the 6x plus 5, plus the 10x plus 1. You know what the perimeter is, 32x minus 7. So we write this as AB. How many x's do I have on the right hand side of the equation? 4 of them, 8 of them, 6 of them, and 10 of them is how many?
28.
Very good. Plus 28 x's, and then if I look at the constants, it's plus
7.
plus 7. Yep, very good. And now, if you got to here, they're giving you achieved. All right, for getting that far. That is very nice of them. But they ask you for AB, so you're going to leave AB by itself and get rid of the 28x from this side and the 7 by subtracting. Yes?
Yeah.
So 32x minus 28x is?
4x.
Yep, 4x. And then negative 7 minus another 7 is? Negative 14. And that very nicely is merit.
And you could do that by just starting at the perimeter and subtracting each way.
Yeah, sure.
I didn't
Sure.
get that. I just had it at 4x. I don't know how you got to negative 14.
Because here, look, you have to take the 28x off. Take 28x off this. You've got to get rid of the 7 from this side. Get rid of 7. So that goes out. 32 minus 28 is 4x. Minus 7 minus a further 7 is minus 14. Right? Look at your signs. Okay, let's move on. Yeah, question.
I just like when the perimeter at the moment is 28x plus 7.
No, it's 32x minus 7.
Yeah, sorry. That's the actual plus with AB in it.
Yes.
And then at the moment it's 28x plus 7 without AB in it. And then what's the difference? And then I just put 4x take 10.
How do you know AB is 28x plus 7? 28x is all the other sides, not the AB.
Yeah, not the AB.
Yeah, so why do you get 10?
I just decided that AB would be 4x take 10 because that's the difference between 28x plus 7 and 32x plus 7.
It's not 10. It's 14. It's 14. Alright. Okay, let's move on to this next one. What do we have to do with this? Please, some people talk about cross multiplying and they get into big trouble. That's why I said to you, cross multiplying is, you can use it when you've got a fraction is equal to a fraction, but in this case it says write as a single fraction, so you cannot get rid of the denominators. Right? You cannot get rid of the denominators. This is like saying 2/5 plus 3/7. Right? When you simplify this, what are you going to do, Megan?
Make the denominators the same.
Yeah, so if you make this 35 and make this one 35. What did you do to the first fraction, the 2/5, to get? Yeah, you multiplied numerator and denominator by 7, so you got 14 on the top. What do you do with the next one? You multiply numerator and denominator by 5, so you get 15. And the final answer here is 19 over the same denominator.
29.
29, my bad, thanks. Alright,
Good correction, Scott.
alright, so when you come to 14 and 15 is 29. Right,
Oh, right.
when it comes to
I see.
putting the algebraic fraction together, what are you going to choose as your lowest common denominator? It must be this denominator and minus 2, that combined. Yes?
Yes.
And then for the second fraction, you want it to be the same denominator. And so you ask yourself,
Expanded the brackets though.
well, don't expand the brackets, please.
It's 2.
Right, so this is 2 lots of what? What do I have to multiply the 2 by? X minus 2. And then with this 3, I have to multiply it by
X plus 1.
x plus 1. Okay? Does that make sense, Takaha? So multiply out the numerator here for me. Yeah, 2x plus 2x minus 4. Yeah. Yeah, all over this denominator. Yeah, so I'm going to write d here plus. Yeah, 3x plus 3. Yes? 3x plus 3. And because I've got the same denominator, I can combine the numerators. So, Patty, do this for me. No, 2x plus 3x. How many x's is that altogether? You're not multiplying them. Yeah, so this is 5x. Negative 4 plus 1 is, yeah, take away 1. Can I simplify that any further? No.
Expanded the brackets, sir.
You don't need to expand the brackets. Like second time I've told you, right? Don't expand the bracket because you may see something that can cancel, right?
Will I still be right though?
You'd still be right, but you don't have to expand the bracket. And really, it's good practice not to expand the bracket. All right? It's good practice not to expand the bracket. So this is marked as follows. If you managed to do this step here, you got achieved. If you got to the end, it was merit. Yeah, Zach. Right, can we move on to the next one? Right, next one. Let's have a look at this. When you get powers, what do you do? Jake, have you done this one? Alright, so have a look at, this one says 2 is being raised to a certain power. What I would always do is have a look at the 8 and have a look at the 20. Can either of those be expressed as 2 to a certain power?
1 at the end.
2, which one at the end? 2 to the power of 1 is 2, then we've got 4, which is 2 squared.
9 and 8.
Yeah, 2 cubed is 8. So the 8 definitely I can write as 2 to a certain power. Can I write 20 as something to a certain power? Because the next one up here, 2 to the power of 4 is 16, and then 2 to the power of 5 is 32. So 20 is not one of the nice ones. So I'll replace this with 2 to the power of 3 times 2 to the power of x minus 4 is less than 20. Right? Can I put the two terms on the left together? Can I multiply them together? Because you've got the same base. So this is a bit like saying a to the power of 3 times a to the power of 2. What is that, Zach? Yeah, how did you do it? Very good. So on the left hand side here, you've got this power 3 and you add on that second power. See that? Well, you've done it here, so I mean you're just using the same rule. In this, look, if I said 2 cubed times 2 squared, you'd tell me it's 2 to the power of 5. So if this was 2 to the power of x times 2 to the power of y, you'd tell me it's 2 to the power of x plus y. Yes? Yeah, so this is no different. This is your x here, this is your x, and this is the second power. So you're just adding the two powers, like you did here, x and y, you add them. That's all we've done. It's nothing. Yeah, Jake.
Could you write it as 2 to the power of x minus 1?
Yeah, so that's what you're going to do ultimately. This is going to become 2 to the power of x minus 1 when you remove the brackets. So all of this is less than 20. Alright? So looking at this, which one of these nice powers of 2 is greater than 20. Is 5, right? So I know that this 20 is definitely less than 2 to the power of 5. See that?
Why wouldn't you divide the 2 by the 20 though?
No, don't, because if you don't do that, you want to write everything with the same base. Alright? You want to write everything with the same base. So that's this golden rule, right? Everything to the same base.
Sir,
Yeah.
could you say 20 is 2 to the power of 4 plus 2 to the power of 2?
That's a very good question. Alright? Are you guys listening? Right, Clayton's saying 20 is 16 plus 4, which is 2 to the power of 4 plus 2 to the power of 2. Right, that's really nice. The only problem with that is, if I want to compare it with this 2 to the power of x minus 1 on the left hand side, can I combine these two powers if I'm adding? No, alright? So you want to you need to write it so that you can combine the powers. So I'm not going to do that, but nice suggestion, Clayton. So if I know this is true, look, we're saying this here must therefore be less than the 5. Does that make sense?
Yeah.
Has to be. So we get x minus 4 is less than 5, and we're solving this. X must be less than
I'll put x must be less than 4.
sorry, this is,
Why have you got 4?
oh my bad, x minus 1, Jake. So x is,
6, less than 6.
sorry, s is less than 6. No, Jake gave it to me. He said it was x 2 to the power of x minus 1. I just wrote it incorrectly. Thanks. Right, so x is less than 6. All right, and here the question is not so great. I would just write for for x being a whole number.
Shouldn't it specify that again at the start?
Yeah, it should, and they didn't. All right, definitely
Every
should.
single time there's something that's just...
Yeah.
So what would you work out?
Hang on.
Like, I just divided 20 by 8, and then I knew that.
Yeah.
All right, if you did it this way, and that's fine too. So let's do it Zach's way. If you've got 8 times 2 to the power of x minus 4 is less than 20, because 8 is a positive number, I can divide both sides by 8 without changing the direction of the inequality. So I'll get here 2 to the power of x minus 4 is less than 2 and 2.5. Alright? 2.5 is definitely less than 4. Yes? And 4 is 2 squared. So look, power and power, comparing the powers, x minus 4 is less than 2, so x is less than 6.
Oh.
That's valid
And
too.
become a whole number.
Alright, yeah, x being a whole number. So you get the same answer. I would generally look to see if you can write the 8 or the 20 as 2 to a certain power, because sometimes you can, and then you don't have to do any dividing. George?
How would you work out whether that's plus negative? No, or equal to, not plus negative.
For this one,
Yeah, would you just put it back into your...
George is asking this, alright, and if you look at their solutions, they also allow this. I don't like it as much. When we get to this stage, 2 to the x minus 4 is less than 2.5, right? 2.5, if I look at just 2 to the power of 1, we know that's less than 2.5, don't we? Yes, I'm saying 2 to the power of 1 is 2, and this is less than 2.5. So your 2 to the power of x minus 4 might be equal to that, or it's going to be less than 2 to the power of 1. Does that make sense? And in this case, then we get x minus 4 is less than or equal to 1, so x is less than or equal to 5. But I prefer this because I know it's definitely less than 6. I mean, that's where the question's at fault, because if x was equal to, let's say, 5.3, it may work, but you have to have that restriction that x has to be a whole number,
And are they...
and they didn't
do
say
they
that.
accept both?
Yeah, they'll accept
And
both.
what was that, if you got it completely correct?
This is merit.
Okay.
Yeah. Okay. Can we look at the last one, part E? This one was, I felt, really quite a nasty question. Other people have said, oh, it's not too bad, it's not too bad. I think it's really quite nasty. Who's tried this? Yeah, so it's, Zach, what did you get? How many students does Leo have?
Can I just give you the two equations?
No, just give me your final answer and then...
Oh, I didn't get a final answer.
Okay, you didn't get a final
I got
answer.
with the students, and I got that the students cost 8.5.
Okay, well, the students don't cost 8.5 because you've already got a cost, all right? So we need to define our variables carefully. Have a look at this. It says George and Leo are organizing 27 people in 2 groups, all right? And they to go to a sports game, and you know this is how much it costs. So you've already got a cost. You've got 27, and the question, if you look, I would always look at that last point here. How many students are in Leo's group? So you need to know a number. What did you define your variables as? Does someone want to have a go? Yes, Clayton.
S as students and A.
When you say students, what students? Their height, their weight, their...
Their number of
Right, so
students.
S is equal to number of students.
Why it?
Why S? S is number of students here.
Oh, yeah.
Alright, and then let's say A is equal to number of adults. Right, what do you know, Zach, about the number of students and adults altogether?
A plus S equals 27.
Sweet. A plus S is equal to 27, right? And then, what do you know about the total cost of the tickets?
30A plus 20S equals 600.
Very good, right? So you've got 30. This is the total cost of the adults plus the... Sorry.
Chaos.
Total cost of the adults plus the total cost of the students, which is 20S, is $650. Can we simplify this? Can you simplify it? Because the numbers there are really quite big. Can I write here that 3A plus 2S is equal to 65? Just dividing everything by 10. Because that makes it easier. Yeah? So I'll call this one equation 1 and this one equation 2. Right, what method do you guys want to use to work out what the A and S values are? Sorry?
A or 1, 2.
Substitution, you mean?
Alright, substitution. So what are you going to substitute?
Oh,
Well, first you go S equals 27 minus A,
S is equal to
So
27
you've got
minus A.
an S value, and then you just plug that into your one below, so you've got 3A plus 2 brackets 27 minus A equals 65.
Does that make sense to everybody? Right, the number of, we've got an expression here for students, and instead of students, 2S. Instead of S here, we're going to write that expression, 27 minus A. Happy? Alright, expand this for me. Let's go, Patty. This is 3A plus 2 times 27, 54. 2 times negative A is negative 2A's. This is 65. 3A minus 2A is what, Will? A. And if I get rid of the 54 from both sides, I'll get the number of adults. What's that?
11.
How many? 11. Alright, so number of adults is 11, and this tells me the number of students must be what?
16.
16. Alright, we're not done yet, hey? We're not done yet. Because if we draw a little table here, we've got George and we've got Leo's group. And if we look at adults and students, we've got 11 adults and 16 students. This is 27 people altogether. And the question says, how many are in Leo's group? Yeah? How many students are there in Leo's group? But what do we know? What do you know about the number of people in each group?
George's group are students,
Half of them are students.
and 2/3 of Leo's.
Okay, so let's give these. If we said George has G, all right, G people altogether, and Leo has L, then I know that half of George's are adults. Does that make sense?
Yeah.
And half of them are students. Whereas in Leo's group, 2/3 are students. So I've got here 2/3 of L, and this is 1/3 of L. Make sense?
Yeah.
Alright, so you have to form another set of simultaneous equations. Okay, it's not as bad as you think. Here we know that half of G, so if we just look at adults, half of G plus 1/3 of L is 11. Alright? And the second one says half of G plus 2/3 of L is 16. So what are we going to do?
Could you use elimination?
Yeah, I would just use elimination. Alright, so if I call this 3 and this 4, I'd say 4 minus 3. Right? Half of G minus half of G is no G's. 2/3 of L minus 1/3 of L leaves you with 1/3 of L. And this is equal to 5. Alright? Does that make sense? And then, you know, we don't even have to find the value of L per se. Okay, you could. But it says how many students are in Leo's group. And if you look at the number of students in Leo's group, it's 2/3 of L. If you know what 1/3 of L is, and you know it's 5, what's 2/3 of L?
10.
Yeah, therefore 2/3 of L is 10. There are 10 students in Leo's group. Now,
I don't really get. I get up to how you get a equals 11 and s equals 16,
yeah,
but I don't get how you go into the
half.
table.
Because over here, Jacob, it says half of George's group are students. So if we let the number of people in George's group be G, half of them are students here, and then the other half are adults. Whereas in Leo's group, 2/3 are students.